Everyone is here. Okay, so can see the
Yes.
Can okay, thanks. Okay, so as I said, partially reflected, partially transmitted, all depend to one property of the substance called impedance. Different tissue has a different impedance. Okay, so that's what we're going to do later. If majority is reflected, only little transmitted, that means the depth the ultrasound can go in will be affected. Okay, so if majority transmitted, only reflected, only little reflected, then the image is going to be more deeper the ultrasound can go. So how deep the ultrasound can go is depend to the impedance. Okay, how much is transmitted. Okay, again the highlighted points. Okay, an ultrasound pulse is emitted. The one I told you, part of the pulse energy is reflected, the rest is transmitted. Okay, and the pulse return to P, and pulse return to P. Okay, and the pulse is written to P. Two information is used to analyze the image. First is the amplitude. Second is the time. Okay, time it takes to return. If time it takes to return is longer, that means the border is too deeper, right? Time taken for the pulse to return is longer. That means that border is too deep inside. Amplitude tells the nature of the tissue, nature of the border. Okay, it tells nature of the border. If majority reflected, they'll tell you it's like a soft tissue. If only little reflected, then they say, oh, that's majority reflected. That means the body got a lot of gas. Your stomach got a lot of gas. The majority will be reflected. Okay, so majority reflected, the doctor will tell you that, oh, your stomach got a lot of gas. Okay, that's why reflected. If majority only little reflected, that means maybe your ultrasound is absorbed by a bone good absorber, so it absorbs a lot. So the amplitude tells the nature of the border. Okay, time tells how deep is the border. So the time taken dependent on the distance, distance, how far, how deep. The amplitude indicates the amount of energy being reflected from each point. Okay, so both. Yeah, so this is the idea. So the manipulation, two factors is the amplitude and time. Amplitude, time, the doctor will check. By checking the amplitude and the time, you will get to know what type of tissue is there. Okay, so now we're going to go a little calculation about ultrasound. Okay. So MRI, no calculation. CT scan got small calculation counting the pixels. X-ray got little calculation about the attenuation and half thickness. And out of the medical, ultrasound is one of the tricky calculations. Okay, so understand the calculation. First, understand this image. When an incident wave hit the border, medium 1, medium 2, partially reflected, partially transmitted. Okay, so in the law of the energy, energy conserved. So the original intensity must be equal to the reflected intensity and transmitted intensity. Reflected. So I equals to IR plus IT. Okay. So the angle of incident and reflected going to be the same law of reflection. Okay. So I equals to IR plus IT. Transmitted plus reflected is the original intensity. Okay. Okay, something new. Acoustic impedance. So as I said, every medium has its own impedance, or better complete wording, acoustic impedance. Acoustic impedance, relative magnitude of the reflected acoustic impedance of the two media. So what is meant by acoustic impedance? Acoustic impedance of a medium, that is acoustic impedance, is equals to it's a product of speed of sound and the density of that material. Speed of sound times density of the material determines the acoustic impedance of the material. Okay, so more faster the sound travel, more denser, high acoustic impedance. Okay, so Z equals to, Z is the symbol for acoustic impedance, equals to density rho times C, speed of sound in that medium. So Z equals to rho C. Okay. So bone has a very huge acoustic impedance because it has a very dense structure. Okay, and speed also reasonably fast. Sound travel faster in the solid, right? So acoustic impedance of the bone. What is so important about acoustic impedance? Next time they'll ask what is meant by acoustic impedance. What is acoustic impedance of a medium? It's a product of speed of sound and multiplied by the density of that medium. Okay, why acoustic impedance is very important? Acoustic impedance determines how much intensity will be reflected. That's the last line. The ratio of IR over I. IR is what? The intensity reflected. Intensity reflected over the original intensity. IR over the I, the original intensity, is called intensity reflection coefficient. IR over I is called what? Intensity reflection coefficient. Alpha is equals to IR over I. Okay. So if alpha is big means what is the meaning of that? Alpha big means majority reflected or transmitted. Anybody? And alpha is big means IR over I. So big fraction, right? That means IR is big lah. So when alpha is big, let's say alpha got 0.7 alpha got 0.7 means what? 70% of the incident intensity has been reflected. 70%. Okay, so alpha. If alpha is big means majority reflected. Just now I told you, right? Stomach with full of gas. So when the ultrasound go from the skin to a gas layer, the skin and gas layer, majority will be reflected. The alpha will be very huge. So according to the formula, the alpha is depend to this formula: Z2 minus Z1, Z2 plus Z1. Okay, what is Z2, Z1? Z1 is the first medium. Z2 is the second medium. Acoustic impedance of the first medium, Z1. Acoustic impedance of the second medium, Z2. So Z2 minus Z1, Z2 plus Z1 determines the alpha. Now this formula tells a lot of things. You see the two medium, the 1 and 2, they have about the same acoustic impedance. Z2, Z1 is quite same. Alpha going to be close to 1 or close to 0. Z2 and Z1 is about the same. Alpha going to be close to 1 or close to 0. So numerator Z2 minus Z1 is about the same. That means the numerator going to be very small, right? Numerator going to be very small. This doesn't make any difference. Up here it's going to be very small. So alpha going to be very small. Very small. So if the two medium has about the same impedance, alpha going to be very small. That means tell me, majority will be transmitted or reflected? Alpha is very small. Alpha very small means the reflected one will be very small. So majority will be transmitted. Okay, you got idea? So that's very important. That's a very important point for you to understand here. When Z2 and Z1, when Z2 is about the same as Z1, alpha close to 0. That means majority has been transmitted. Majority has been transmitted. Okay. If Z2, Z1 is about the same. If Z2, Z1 big difference, alpha going to be very big because numerator will going to get big. Z2 minus Z1 big means numerator will get big, alpha get bigger. So more will be reflected. So alpha increase means reflected intensity increase. Okay. Any questions? Okay. So now tell me. Okay. Before that, let's go ahead. Okay. One example. See here is some values from the medical field. So these are the acoustic impedance for different type of tissues, substance. Bone has the highest acoustic impedance. Soft tissue, okay, reasonable. Okay, the others are small. Air got a very little acoustic impedance. This is the speed of sound in different medium. Okay. Okay. So yeah. So you can see now, if a soft tissue, your skin, from skin, after ultrasound passes your skin, then get into the stomach, but stomach got a lot of air. So soft tissue and air, you see the acoustic impedance. Soft tissue is 10 to the power of 6. Air is 430. A big difference, you know. So Z2 minus Z1 will be very big difference. So majority will be alpha going to be big or small. Z2 minus Z1 very big means alpha get very big. Majority will be reflected. So that's why a patient have stomach got full of gas, lots of gas. He drink lots of, I don't know, his body produce lots of gas. Difficult to go for ultrasound. Wait for a while to clear the gas. Okay, you have to clear the gas, then only you can go for scanning. Okay, this acoustic impedance information values will be given in exam. No need to remember. Any questions, guys, from here? So hope you understand. Very important formula. Intensity reflection coefficient alpha. Greater the alpha, greater the intensity reflect. What is acoustic impedance? It's the product of speed of sound and the density of that medium. Okay, so one example. So find the alpha of air and soft tissue. Air and soft tissue. Air you see up here, air 430. So you put into the find the alpha. Alpha is found to be 0.9999. Means what? 99.9% of the incident intensity going to be reflected. Alpha 99. This 99.9% will be reflected. Muscle to bone. You check muscle to bone. Muscle to bone. Muscle check muscle. Muscle the value 1.7 times 10.6. Bone is 5.6 times 10.6. So you put that bone. Yeah, that value 1.7. Yeah. So it's 0.343. That means what? When soft tissue go to bone, 34.3% will be reflected. Okay, 34.3% will be reflected. Yeah, 65.7% will be transmitted. Okay, so alpha value is very important in ultrasound. Okay, so using the data and table suggests why, although the speed of ultrasound in blood and muscle is approximately the same, the specific acoustic impedance is different. Why the blood and muscle has the same speed, but acoustic impedance is different? Of course, another factor must density different, right? Their density is different, so acoustic impedance is different. So calculate the intensity reflection coefficient for the parallel beam ultrasound. Normally, boundary between fat and muscle. So put fat and muscle into the formula. This formula also exam given, but Z2 minus Z1, Z2 plus Z1. In exam, they give, but better remember. Don't rely to them. So 9.4 times 10.93. Tell me, majority reflected or majority transmitted? Alpha is too close to 0, right? So majority transmitted. Majority transmitted. Put it in mind, bigger the alpha, more will be reflected. More will be reflected. Bigger the alpha. Alpha value always 0 to 1. Maximum can go is 1.
Is the Z2 Z1 or Z2 is the original medium that the wave is going?
Z1 is the original medium.
So the boundary after the boundary is Z2.
Yeah.
Okay.
Okay. But here you messed up the number. Also doesn't matter. You get the same answer because square one. So, but always Z1 is the first medium. Z2 is the next. Okay. So that's why people going for ultrasound, when they put the transducer, okay, the transducer direct to the skin, the transducer come out, there will be a small air layer. The air go to the skin and skin, has a big acoustic impedance difference. So air to skin, majority will be reflected. So cannot do the scanning one. So what they do, they apply a gel. Transducer is placed in a contact with the skin with the gel acting as a coupling medium. Gel is applied as a coupling medium. What gel does, when the ultrasound comes out from the transducer, it passes the gel, and gel from the gel it go to the skin. The gel and skin, the gel used must have the same acoustic impedance as the skin, so that majority transmitted. Okay, the gel reduces the size of the impedance changes between the boundary, reduces reflection at the skin, enabling more wave to enter the body. Okay, pointless if the ultrasound leave here itself, never used to scan the body. So use a gel have about the same acoustic impedance as the skin, so that majority transmitted. Okay, any questions? No questions, Okay. So now we talk about reflection. Now we're going to talk about absorption, like what happened in X-ray. When ultrasound come to the boundary, soft tissue and bone, okay, partially reflected, partially transmitted. On the transmitted one, when go in, absorption happened. The medium absorbs some ultrasound. So originally I naught become I. This I naught after passes the boundary lah. Assume it's inside the bone ready. I naught after it crosses a certain thickness, it become I. So how the I and I naught related? I equals to I naught E negative KX. Same as your what do you call X-ray. X-ray and your half-life formula. So I is the original, I is the intensity still remain. I naught is the original intensity. X is the thickness. K called absorption coefficient. Okay, recent Cambridge paper, they never use K. They use I equals to I naught E negative mu X. Sometimes they use mu. So mu also absorption coefficient. Absorption coefficient. Okay. The K or mu, if the K or mu very high means, what is the meaning of that? Very high. K is dependent to the, the factor of K. K is dependent to the type of medium, type of the tissue. Okay, different tissue has a different absorption coefficient. Okay, different tissue has a acoustic impedance. Different tissue has a absorption coefficient. Okay, that's a different absorption coefficient. Okay. Bone has a very high K or mu. It has a very high K or mu. That means majority will be absorbed, pass through the bone. The K and X make sure same unit. If a K per centimeter, X must be in centimeter. Okay. Any questions from here? Okay, so I proceed. Okay. So now one example. Okay. A parallel beam is ultrasound is incident on the surface of the muscle and thus passes through a thickness of 3.5 centimeter of the muscle. It is then reflected at the surface of the bone and written through a muscle to its surface. Using data from the table, calculate the fraction of incident intensity that arrive at the surface of the muscle. Okay, what they are trying to say. Okay. So down here is muscle. Okay, sorry, up muscle. Okay, so down here this is your bone. Okay, up is muscle. Okay, this upper layer is muscle. The muscle is 3.5 centimeter. So from up to down, the muscle is 3.5 centimeter. Okay, of the muscle. It is then reflected at the surface. So an incident I, a wave, I put the number I naught. I naught, original intensity, go to the muscle, penetrate the muscle, and when come to the bone, when they come to the bone, it is then reflected at the surface of a bone. When come to the bone, it was reflected and reached the muscle surface again with the I intensity. Okay. So using data from the table, calculate the fraction of incident intensity that arrives at the surface of the muscle. What do you want? From the table, calculate the fraction of the incident intensity. Fraction. Fraction means what? I over I naught, how much they are asking. Okay, what is the receiving intensity over the original intensity? How much fraction? Okay, here I teach you one shortcut. So I stop here. I'll show from here. Okay, you see, this is two layer. Okay, this is your muscle, this is your bone, and come here, reaching here. Okay, I naught I. Okay, remember, we know I is how many times it has been. This is what happened first. First, what happened? First, what happened at the first? Absorption happened. Yeah, absorption happened. I naught when go to the one, absorption happened. Then at two, what happened? At two, reflection happened. Okay, partially reflected. And three, what happened again? And it goes up. Again, absorption happened. Okay, I tell you the shortcut. The I here and the high here related to I. How many times absorption? 2 times absorption. So first absorption. First time absorption. What is the formula? I equals to I naught E negative. I put K lah. Kx. Okay, Kx. Okay, this is the formula. This is the formula for one absorption. Just one way going down absorption. So this is your I naught. The I here is this I and this I naught related to this formula. I equals to I naught E negative Kx. This is one absorption. Okay, first absorption. Okay, next reflection, right? Reflection how related? Reflection IR over I equals to alpha. Okay, IR over I equals to alpha. So IR equals to alpha I, just alpha. Alpha. So what do you do? Just multiply by alpha. This is what? This is second is reflection. It's reflection. Reflection of what? Medium 1 to 2. 1 to 2. 1 to 2. Then third, what happened? Third, again absorption. Absorption just times with E negative Kx. That's it. This is also absorption. Okay. Absorption, the K should be K of what? K of the 1 or K of the 2? K of the muscle or K of the bone? Absorption happening where? Absorption happening in the muscle, right? So you must use K1 lah. K1, both are K1. K of the muscle. K1 is muscle. Okay. Absorption coefficient of muscle. That's it. Okay. I mean the final intensity is what? I equals to I naught, the original intensity, E negative Kx, we can write as negative K 2x. Okay, two times then times alpha. That's it. This is the formula used. Whenever there is absorption, whenever there is absorption, just use E negative Kx. Okay. E negative Kx. Absorption. If it happens in muscle, so K1, muscle K of the muscle, X is the thickness of the muscle. Whenever reflection happens, just use times with alpha. Okay, always I, the final I to the original I naught you write. What you're going to write at the side is absorption means E negative Kx. Reflection means alpha. Absorption again E negative Kx, and so on. So you got idea? Any questions you don't understand? Okay.
So
Let's go back.
is I not the same as IR?
Which one?
Is I not the same as IR?
I naught is the original. No. IR is different. IR is happening here. IR is happening in the intermediate stage. I'm just linking from the final intensity to the original intensity. That's it. IR happening here.
Means the incident wave I in the first equation is the same as the I naught for the other equation.
Okay, hold on. I think you messed up. This I is the final I.
Okay, final I.
This I naught is the original one. Okay. If 2 times absorption happen, 2 times you write E negative Kx, E negative Kx. Got one reflection, just multiply by alpha. It's automatically linked to final to initial.
But
the IR in between. Yeah.
Did IR go?
Okay.
Where did Where did IR go?
IR has been already considered. IR is a part of. Okay, you want to know IR? Okay, let me see. Again, 3 material. Okay, so the original one is I naught. When reach here, let's say I1. Reflected, let's say I2. Reach up here, let's say I3. Okay. So how I1 and I0 related? I1 equals to I0 E negative Kx, right?
Yes.
How I1 and I2 related? I2 over I1 is equals to alpha, correct?
Yes.
How I2 and I3 related?
Oh.
I2 E negative Kx, correct?
Oh, yes.
But what relation we want? We want I3 connected to I0. We want how I3 connected to I0. We want here I0.
Yes.
We want here I0. So how do you do that? So I3, I2 E negative Kx, right? I2 we know what? I2 we can put it in terms of I1 alpha, right? I2 is what? I2 is I1 alpha, right?
Yes.
So we put here inside here. But I1, do you know what is I1? I1 is this one. Put it inside here. So finally what happened, Finally what happened? Okay, I0, because I0 E negative Kx alpha E negative Kx. I get this formula.
So that means that it is absorption and then reflection and then absorb again.
Yeah, absorption, reflection, absorption again.
Okay,
so the intermediate intensity all has been considered in between.
Okay.
But you remember only this is enough. Okay. Let's say I tell you there is another 3 layer. This is never happened, but I tell you. It goes like this. Go deeper. Come up here. Okay. How this I and this I not affected? 1 to 2. So how do you write? I equals to I naught. First absorption is what? First absorption E negative. Which K? K1. The first thickness, let's say, is X1 lah. It's X1. Second thickness, let's say X2. So put what? X1, right? First absorption. Then at the second, when you reach the border, what happened? Reflection happened, right?
Yes, that uses K2 and X2.
Is reflection right? Do you times here with alpha?
Not yet.
This one is you are taking the transmitted one. You're not taking the reflected one, right?
Okay.
You're taking the transmitted one. So what do you need to write? 1 minus alpha.
Oh.
Here, the first case, you reflected one alpha. If you take the transmitted one, 1 minus alpha.
Oh.
The 1 minus alpha, which alpha? Alpha between 1 to 2.
Yes.
1 to 2. Got it, Okay, next 2. 2, what happened? 2 is absorption, right?
Yes.
So it times is what? E negative, which K? A2.
The second. Okay.
Okay. Then come to 3. 3, what happened? Reflection happened. Let's say you have third medium here also. Reflection happened. So what do you put? Times with what? Times with
Alpha.
alpha. Which one? Alpha 2 to 3.
Yes.
Then the fourth one is what? Absorption again. So you do what? E negative K K1. A2 X2 again. This is the formula. The massive one. Never happened. Normally this is what normally they ask.
Okay.
Just one layer. You got idea?
Yes.
Okay. So no need to go like one by one. If you go one by one, you get confused. Just beginning to the end. If absorbed, just E. If reflected, alpha. If the one transmitted, use 1 minus alpha. Okay. Any questions? No questions. Okay. That's a calculation here. That's a calculation here. You see the beam through the total thickness. So yeah, you see the final answer. Final answer is as I take I equals to I naught E negative K 2x times alpha, right? So I, you see this I naught E negative Kx, they got 0.2 I naught. It's obtained from the previous example. You see the final answer. Therefore, the fraction received back is 0.34. You see the final answer. 0.34 is what? 0.34 is your alpha. 0. This is your alpha. So your alpha 0.34. E negative Kx is what? This E negative K times 2 already, you know. This one they already times 2, 0.2. So the E negative K2x is 0.2. See the final answer is what? I over I naught is what? 0.2 times 0.34 only. 0.34 times 0.2. This is what has been intensity received. The fraction of intensity received. One of 15 is the one received back. Okay, any questions? Okay, so I hope this is the most difficult calculation, but if you follow the technique I told you, reflect, use E. Absorb, use E. Reflect, use alpha. Transmit, go down. After border, transmit, use 1 minus alpha. Okay. But when you use E, use the K1, X1, the thickness of the medium it's traveling. Okay, so yeah, so that's the part of calculation. Okay, let's say I straight away go to one calculation. The back got question. Okay. Okay, you see one question. So let's give a try. The last part for today. You see the data acoustic impedance, coefficient of muscle, and bone given. Here muscle coefficient, acoustic impedance, and absorption coefficient given. So yeah, this is the alpha. So now they're telling this 11.2 story. Attenuation of ultrasound is muscle follows a similar relation with the attenuation of X-ray matter. The parabeam ultrasound X-ray eye enters the surface of the layer of a muscle of thickness 4.1. Ultrasound enters the muscle layer with the intensity of I, okay, 4.1 centimeter. Then the ultrasound is reflected at the muscle bone boundary and returns to the surface of the muscle. Okay. Okay, so muscle to bone, then bone to muscle back. How many times absorb? Twice absorb, right? The same story just now, right? It goes here first, one absorption. E negative kx to be used. K use the K of the muscle, thickness of the muscle. Then it will be reflected. Reflected use alpha, number 2. Alpha use what? Alpha 1 to 2. Then third one, absorption again. E of K X again muscle both muscle. You got the final answer, final intensity. But here the question they're going to part by part. First, the intensity of reflection coefficient of the muscle bone boundary. What is intensity reflection coefficient of a muscle bone boundary? What is alpha? They're asking. Okay, what is alpha? Calculate. Use the data. Calculate. Okay, so you need to put Z2, Z1 minus Z2, Z1 plus at the bottom. You see the value muscle bone, big difference, right? Reasonably difference. So your alpha going to be close to 1 or close to 0? So first answer, the coefficient is 0.33. Oh no. So majority, only 33% is reflected. 33% has been reflected. Okay, so 33 reflected, 0.33 your alpha. Alpha is 0.33. Then second, the fraction of incident intensity that is transmitted from the surface of the muscle to the surface of the bone. Okay, second one, what they ask? How much has been reflected? Reflected. So find IR lah. IR is what? IR is the fraction of the incident intensity that is transmitted from the surface of the muscle to the surface of the bone. The fraction of the incident intensity that is transmitted from the surface of the muscle to the surface of the bone, or transmitted. That means still absorption, still absorption. That means I naught go and reach the surface of the bone is I1. They're asking what is I1. So how do you find I1? I1 equals to I naught E negative Kx. Negative Kx. K is what? Which K? K of the muscle. K of the muscle. 23 per meter. X is what? Thickness of the muscle, 4.1 cm. It's a trap. You see, absorption they give per meter, X given in centimeter. So change thickness to meter. Okay, so that's the second answer. You see the second answer, fraction E equals to negative mu X. So negative 23, the thickness of the muscle. So this the E equals to negative mu X value, 0.39. Okay, now the final question, the intensity in terms of I that is received back to the surface of the muscle. What is the final intensity? They're asking for the final I. So final I is 2 times absorption. This is your E negative mu X square, right? So mu 2X what? So 2X square times alpha, 0.33 alpha, 1 time reflection. 2 time absorption, 1 time reflection times the original I. You get the final intensity reached the surface. Actually, this is what? This is your I equals to I naught alpha E negative, okay, mu 2x lah, 2x. The I alpha is how much? Alpha is your 0.33. Your E mu 2x, actually E negative mu x is 0.39. So this is 0.39 squared because 2 squared. Then you get the answer. This is your I naught they put as I. Find that final intensity. Hey guys, do you understand how the question goes on? Any questions? Okay, no questions. Okay, class. So I stop here. Another one lesson. We finish this topic already. Tomorrow we will finish the topic. After that, it's no calculation. Just fact to remember. Okay, so another one lesson. We finish it up. Okay, so I stop here. Any questions? No questions. Okay, thanks.